the sessions moderator is Richard Harris. Richard, as I think most of you know, is a reporter for NPR. I listen to his stories, his reports very regularly on my commute, evening and afternoon, and I've watched a lot of his reports on the spill. In fact, I think he was maybe the first or one of the first to really start digging into the story about whether the initial reports, I think it was it 2,000 barrels a day or whatever it was a gross underestimate, and the flow coming out was much, much higher. That's an example of Richard's great reporting. I also wanted to, while people are selling, to sort of tell a little story here. He's also a really decent human being. And he kind of caught me interesting. About 9 years ago, I was at the Johannesburg Summit. It was the Rio Plus 10. And, we're going in Rio Plus 20 next year. And I happened to be in the press room doing some emailing back to my family or something. And Richard was doing a story about carbon offsets, and he happened to see me there at the computer, and he came over. He said, can you help me with the story? And of course, the media come up, and you want to be on a story? He said, sure. So it ended up, the story was I going to pay $60 or $70 for my carbon offset for my flight? And of course, when the microphone's in front of you, you say, of course, and you grab it, Kyle, and you pay for it. And so that was the end of the story. And about a week later, I got an email from the carbon offset company that said, Richard Harris just paid his carbon offset too, not paid for by NPR, paid out of his own pocket, and there was a note, something to the effect of, thanks for being a good sport, Pete. So thank you, Richard. I've remembered that ever since, and now we have to do carbon offsets whenever we travel, and hopefully many of you did that when you came to the conference. So on that note, let me now turn the microphone over to Richard and another great session. Thank you.
Thank you very much. And I walked over here, so I didn't have to pay a carbon offset to get here today. So that was a big relief. So anyway, welcome everybody. We'll keep this lively this afternoon since you've all had a little bit of food in your stomach, and I know that it's a good challenge to stay awake, but I've been chatting with these guys at lunch, and we are going to keep you awake, I promise. So let me make a couple of really quick introductions, and then we're going to just plunge into a conversation here that will take about an hour. So immediately to my right is David Yaskowitz, who is basically an economist, socioeconomics, is that right, at Texas A&M, and I will be throwing questions to him about the economic and social human impact of the spill. To his left is Pete Peterson, who is a professor at University of North Carolina, and his claim to fame is following the Exxon Valdez spill for these many years, and it's obviously really interesting to compare what happened in 1989 up in Prince William Sound to what happened in the Gulf of Mexico last year. So we will. I will turn to him for those questions. To his left is Ed Overton, who's an emeritus professor, although he's been working full-time, emeritus in quotes for sure, at Louisiana State University, studying the coastal environmental issues and so on. And last but not least is Russ Tunnell, who's also at Texas A&M, and he actually will bring us back to another huge spill in the Gulf of Mexico, Ixtoc 1 in 1979. So also very important lessons to learn from that as well. And one of the sort of overarching questions is do we have really enough information to appreciate the impacts, both biological? We're starting to hear some of the data gaps, the big question marks still in understanding that. But what about the economy of this? I know that like NSF had prompt grants that went out. A lot of people went out and started doing research right away on some of the biological and chemical systems. What about the economics of that? Was that responded to in the similar way?
I think looking into the future, there's uncertainty, obviously, and much is going to depend upon what happens in the biological, physical systems. What we don't have a lot of information on is, once again, getting back to this natural economy, these services, ecosystem services that we're talking about, and how much we rely on these. I mean, we may not know that that marsh and that oyster reef out there are doing those things that are impacting our well-being, but once they're gone, then we feel the effects. And we don't have a lot of information there, and that's where we need to be putting resources into the future. But there is, I mean, you know, the agencies are stepping up to that. EPA, NOAA, USGS, they're all stepping up and saying, okay, ecosystem services, assessing those, valuing those is really important, not just for this event, but just in general, if we're going to make better decision-making with regards to our natural resources.
Yeah, and Ed Overton, I'm sure that's something you've been looking at over the years, because it's not just the oil spill that affects those marshes, but clearly the history of the oil and gas industry in Louisiana has been cutting channels and degrading a lot of those wetlands to begin with. So, I mean, how do you compare what you've seen over the last several decades to what's happening now in a much more, maybe in a more prompt and certainly more dramatic fashion, but
Well, the Delta is clearly a very, very sick part of our environment. It's the one thing that would strike me every time I fly over is just there's not much left. It's just amazing. You look down, you see where canals were drilled, and you can see the sparrow bank, but there's nothing around them. It's open water. All of that used to be coastal marsh. So that's the real story. I mean, the oil spill is a hiccup on the side of a massive loss of a national treasure, our coastal wetlands, which protects it, which serves as the breeding ground for all the organisms that we've talked about today. That to me was the real story, to be just blown away at how much we have lost. If you look at a map of South Louisiana, you're not looking at hard land. That is a figment of somebody's imagination 20 or 30 years ago. Doesn't look anything like that now. Look at any satellite photo and you'll see there's a little sliver of land that follows the Mississippi River. The rest of it's open water. You know, 30, 40 years ago, it was all marshland. So
Yeah.
big problem.
yeah, the Oil Spill Commission did, one of its recommendations is to take the Clean Water Act fines that BP will ultimately pay, perhaps, and invest that essentially, most of that, 80%, if I recall the number, in essentially trying to restore the delta, thinking about some of the nutrient overloading issues as well, things that are not related to the oil spill, but are sort of the long-term consequences, and I guess not only of the oil and gas industry down there, but of you know, all the nutrient overloading that comes down from the Midwest, from the breadbasket, the place that grows the food that we eat. Does that, I'm presuming you think that sounds like a sensible idea?
You better believe we think it. I see Dr. Turner down here, who's and Nancy Rabelais, who are big proponents. They know a lot more about this than I do. But everyone along the Gulf Coast expects that most of that money will go to some sort of reasonable restoration plan, but not. It's for the Delta. If we don't restore the Delta, we won't be talking about the fisheries in 20 to 30 years we're talking about now. We won't be talking about the infrastructure that supports oil and gas. If we don't support the oil and gas, we won't be talking about driving and flying to Washington, D.C. for this conference. There's a lot of things we won't do if we don't protect that environment.
And Pete, you wanted to add a word, and then I'll go to some, we have tons of questions from the audience.
I did. We're talking about the bigger picture issues of multiple stressors in the system. I want to refer people to a product of the U.S. Global Change Program that was orchestrated, funded by Congress, orchestrated through EPA, called the SAP, S-A-P documents. And SAP 4.1 was written by Rob Taylor and a group of coastal geomorphologists and geologists. What it does is give the results of a bathtub model of where the waters will be and where the land will be in certain times into the future on the basis of assumptions, realistic assumptions of sea level rise. That model shows that the problems that we've seen in the Gulf and in the marshes of the Delta are just the tip of the iceberg of what's coming. And what that means is that one has to be very careful in designing restorations for this spill so that the restoration is sustainable and so that what you do has resilience. And that applies to the human systems as well. So we have a huge task ahead, and that is to create a sustainable ecosystem that is resilient and continues to affect the socioeconomics of humans that live there indefinitely in the face of major perturbations and those include sea level. And I should add, this SAP 4.1 modeling, so-called bathtub modeling of sea level rise, is a gross underestimate because it fails to include erosion. And if any place is eroding with storms, I can pick one, and that is this one.
And subsidence, too, for sure. Let me go to some questions here, and here's the first one. It says, the EPA has provided the composition of Corexit 9500 used to chemically disperse at depth and at the surface. You keep mentioning that the dispersant is toxic, yet all of the components of Corexit are used in food, baby subs, laxatives, et cetera. Can you comment on why it is called toxic? Ed, do you want to take that?
Well, dispersants have a long history, a long sordid history. Initial dispersants were very toxic, caused more damage than the oil back in the Torrey Canyon days. But the modern dispersants are much better and less environmentally damaging. By the way, NALCO provided me and anybody that asked, as far as I know, the composition of the dispersant. So this wasn't a secret. I asked and was immediately given, this is what's in it. They didn't tell me the composition, that was the proprietary, but the chemicals that were in it. And basically they were all licensed by FDA for use in foods or around foods. In most of the common foods that we eat every day, some of those chemicals that were in that dispersant. So that doesn't mean I would eat the dispersant.
Right.
By any stretch of the matter. It was a soap. It was a strong soap. Didn't taste good. That doesn't taste good. But the real damage from dispersants is in the dispersed oil. You're taking oil that's thick on the surface, spreading it out over a larger area, and those components are now available, so you have a route of exposure to the organisms that are floating around there. By dispersing it, you also make it more bioavailable for bacteria, and you degrade it. So it's a trade-off. There was a trade-off from dispersing offshore versus letting the oil come onshore, and that will be debated for many years to come, whether it was a good idea or a bad idea.
Yeah, and I know the EPA tested the toxicity of this, and it was moderately toxic to two different species of organisms in the Gulf. Clearly, oil itself is more toxic than the dispersant, the EPA said, but obviously the dispersant itself did carry some toxicity as well. And Pete, did you want to add something about that?
And by the way, you can't test it for all the organisms, so you always use two indicator organisms, whether they're right, and they were not subsurface organisms. So we don't know the toxicity subsurface.
Yeah, I have a few things to add, as you might expect. First of all, the organisms weren't necessarily organisms in the Gulf. They were sort of Cereodaphnia and this and that are standard EPA test bioassay organisms. These are kind of like lab rats. You can't kill them with a stick, but they're good for living in the lab so you can run toxicity tests. They were short-term toxicity tests, testing only acute toxicity, not the chronic exposures that we've recognized in the Exxon Valdez are critical. The chronic exposures to some of these toxic components don't necessarily kill, but they affect behavior, they affect growth, they affect reproductive output. These have a longer time frame to exhibit themselves in the system, meaning that those of us who say the oil is gone, things look great, not too many dead things, are premature. And furthermore, that hasn't been done in those tests. It will be done. I understand there are tests that are now going to try the right organisms, some at depth, some, those from the Gulf, and over longer periods of time. The other thing about this is, and Ed's answer raised an issue that I wanted to, a bone I want to pick. We make the assumption, a whole lot of people make the assumption, I bet we'd get, you never get 100%, but we get a big percentage if we do a show of hands here in the office and in the crowd, we make the assumption that the application of the dispersant was what led to the massive amount of dispersion of this oil, the breaking up into small bits, the higher rates of biodegradation, the minimal amount, relatively speaking, that got to the surface. Well, the natural physical processes by which this oil and gas mixture was released led to dramatic natural dispersion of that oil. This was under high pressure in very cold water that entrained very cold seawater with dramatic mixing, as that camera showed us day after day. That created a natural dispersion. So the jumping from that to the conclusion that it was addition of the toxic, mildly, chemical to it is not supported by any data that we have. Furthermore, Oil chemists say that the mousse that reaches the surface is not something that can be readily dispersed by application of the dispersant. So there goes, I don't know how many million gallons, maybe close to one. I think it was 1.8 million total that we added of Corexit gallons. There goes a whole chunk of it. Then those who have looked at those films and tried to document whether the Triton prongs of 3 prongs of the dispersant delivery system actually shot into the release or not, come up with the conclusion that it very rarely hit its target, thereby casting doubt. And this falls in a broad general category of why don't we, as a system and as an industry, get together and test response issues. And it's not just the effectiveness of the materials and whether you're getting them in and they're doing something that we're sort of making policy in the absence of. It's also looking at the negative impacts of many of these response actions that we take. And the response actions can be as damaging as they are helpful, such as building berms to protect Grand Isle and doing other things that I can go on about piece by piece that have injury that may be worse than the cure.
Okay, thank you. Let me take another question. The question is, what has happened to all of the skimmed off collected oil and all the absorbent materials, booms, et cetera? The questioner asks, is it a problem somewhere else now? Ed, I guess, or? Obviously, the oil that was collected and brought onto freighters and oil tankers was brought ashore and was produced as oil, I guess. But what about the boom? What about the stuff that was skimmed off, which was, I guess, a very small percentage?
And all
of
the ships and crew boats that had oil all over them, they were brought in and decontaminated. That oil was collected, and I'm not sure where it went from there, whether it was landfilled, went to hazardous waste disposal. Don, do you know what? Here's a commissioner down here.
Most of the boom material absorbent booms were landfill.
Absorbent booms were landfill, the stuff that you couldn't clean up. The deflection booms were cleaned and went in storage. The oil that was skimmed, I'm not sure. By the way, skimming oil allows the oil to be removed from the environment. So if in my way of thinking, if we have a response option, skimming would be the first choice because you're removing oil from the environment and you can recycle oil. In that, so everybody is in favor of recycling. It's easier to say than to do. It's difficult, technically difficult, particularly when you don't get in and get fresh oil. You've got to have skimmers. They got to get out there where the oil is fresh to get it up. But when you burn it, you basically skim it up, but instead of collecting it, you burn it. You'd create a water problem into an air problem. So why not skim it and recycle it? And then, of course, dispersants were only used well offshore. There is a lot of data, despite what Pete's saying, that people went out and monitored the effectiveness of dispersants. I'm not privy to all that data, but I know it was collected. I've seen some of it, and that was part of the incident response. We will find out over the next few years how effective it is, just because we don't know now. Tens of thousands of samples were collected. Only a small fraction of those have been reviewed outside of the incident command. So over the next several years, we will be in the process of looking at how effective were the dispersants. We really don't know right now, and so I hate to say one way or the other. But there were dispersant monitoring programs. There's anecdotal evidence that use of dispersants at the wellhead prevented the oil from coming straight up, which was, of course, where the recovery vessels were. Now, that needs to be validated, but I've heard that from several people in the Coast Guard, that when they did not use dispersant, there were a couple of times they ceased using dispersants at depths, they had a vapor problem at the surface. So all of this picture needs to be put in place. We don't know with any certainty a lot of the details yet. A lot of the data was collected, massive amounts of data. We don't know how much oil is on the bottom. I personally looked at maybe 100 or 200 samples, sediment core samples, and there's not black oil in those samples. There are trace levels of polycyclic aromatics. The highest concentrations are within a couple of miles of the wellhead. They're on the order of 10 to 50 parts per million total PAHs in the wellhead. So there's not a black layer of oil on the bottom of the Gulf of Mexico. There's a black layer of oil on our coastal marshes where they got impacted.
There is a brown layer of goop at the
There's a
bottom.
brown layer of goop that cannot be fingerprinted to the oil. And again, this is data that's been collected. We're still trying to figure out what all this means. So for me to stand up, or anybody else to stand up and say we've got anything close to a comprehensive idea, we don't.
Yeah.
But having said that, I looked at a couple of hundred samples, and there's not black oil in those samples yet. We may find some, but knock on wood.
Right. The carbon, of course, the carbon is still out there, and it'll be really interesting to see how that cycles through the ecosystems, because it may not be oil anymore, but it's certainly a big load of carbon. Let me turn to Wes and ask about the data question here, because you mentioned that the sort of the tragedy of Ixtoc was that basically the research dollars dried up right away. Do you have a sense, I don't know if anybody has a broad enough encyclopedic sense of whether there's been enough research money spent here to now and looking down the road to really be able to look back in 10 years and say, we really do understand what the impact of this oil spill was?
I think that we're on the track to doing the right thing now. There have been more samples taken, like Ed showed. If you've ever gone to the NOAA website and seen the NODA by the numbers little chart, 30-something thousand samples taken. It's just huge numbers. And then academic research, NSF put out 40 or 50 rapid grants right away. BP has promised the $500 million in Gulf of Mexico Research Initiative. $40 million of that has already been put out. We're hoping in the community that we'll see the RFP for the next $50 million. It's to be $50 million a year for the next 10 years. If that works out, it'll be unprecedented for the knowledge that we'll learn from this spill. And so I'm hopeful that good things will be coming for the research community. EPA and NOAA, NSF, all of these have plans for research opportunities.
Yeah. Pete, do you want to add something quickly? And I want to get to more questions.
I do quickly. And that is to say, a lot of what we wanted to know, we didn't have the money at the time in state hands or in federal hands to go out and learn it. We also didn't have the plans in place or the research platforms, the submersibles and the other ocean-going vessels to look at it. Remember that the dispersal, while successful in one sense, not sending oil to the shore, made it available to suspension feeders throughout the water column, and that we needed to be out there to look at. We may cleverly now know things about food chains and use higher trophic level organisms that we could trace back to problems that happened lower in the food chain, but that's a little dicey and needs some people smarter than me to do it.
Okay, next question. What about the dead turtles on the beaches? Were those because of the effects of oil, or because the shrimpers knew they had a free pass and stopped using the turtle extruder devices and other precautions? What is known about the turtles? Ed, did you, or Wes?
Well, there's a very strong tracking program for dead turtles coming in. And I don't know the numbers personally for the northern Gulf of Mexico, but there's a certain number that normally comes in. There was a lot of attention obviously paid to them. They're part of the charismatic megafauna, as we say. And so there were turtles that were brought in that were oiled, some that died eventually, some that were oiled, cleaned, and released. There were others that washed in dead that didn't have any oil on them at all, and they're probably a part of that natural cycle that we see each year. And so the numbers are still not clear where they're going to wind up.
Okay. Here's a question of, somebody mentioned this a little bit already, but do you believe that the emergency creation of the barrier islands off the coast of Louisiana was useful, positive, or negative impacts? You want to take that, Ed?
Next question again. The governor and people in Plaquemine Parish have taken a lot of criticism, and a lot of it is correctly placed. But the house was on fire. You got to remember, back in May, in the middle of May, we went from 1,000 barrels a day to 5,000 barrels a day, to 12,000 barrels a day, to 19,000 barrels a day, and it was heading up exponentially. And the experience in the Exxon Valdez was that there was a black tide that came ashore. And that's all those people down there saw, was a black tide of oil coming ashore. And so they said, gosh, we've got to do something. We put booms everywhere, which were virtually ineffective. And somewhere in all of this melee, the idea of building the sand berms came up. And apparently they have been used effectively in certain parts of the world. I don't know anything about that. But I'm going to not be as critical as some folks. The house was on fire, and we didn't know what. Now, some of us didn't expect a black tide to come ashore, but we weren't consulted by the governor. So I'll just let it sit at that.
Okay, that's good. And here's a question for you, Wes. What do we know about the impacts on bluefin tuna and other species reproducing in the area at the time? I guess it should be said that the bluefin tuna, they aren't fished in the Gulf, but the larvae, I guess, are developed there, and then they expand out through the Atlantic Ocean, right? And so
Yes, that's correct. In fact, they have two places they spawn, one over in the Mediterranean and one right where the oil spill took place. So there's huge concern among the scientific community about the bluefin tuna and the eggs that may have been impacted there. It's a long-lived species, and if you take away a year class, it's not that you just lose that. It could be a decade or more before you see the repercussions of that. So that is a real species of concern, and time will tell us what actually happened in that.
Yeah, I guess obviously they're under huge pressure from overfishing anyway, so it's a species that's in grave danger to begin with. I actually, just by coincidence, had called some folks at NOAA earlier this week, and they said they're still crunching this data because it's an interesting question that a lot of people want to know the answer to. Another question, a new deepwater area was closed to fishing late last year after tar balls were brought up in shrimp trawls. Are there still unfound sources of oil in the deep Gulf, and if so, on what scale? And I guess we need to clarify, first of all, whether we think these tar balls are from the BP spill or whether these are from other rigs, or obviously there are also natural seeps as well.
That was from the Big Red. This trawl is several 100 meters down. And those tar balls, so that from the name of the vessel was Our Mother. So the shrimp vessel Our Mother collected these tar balls. They did not, I've seen the data, they did not match fingerprint to the Macondo oil. They were clearly tar balls, they were not Macondo oil. We're supposed to, in the process of getting additional tar balls from that closed, it's now a closed area to shrimping. And we had not gotten those tar ball samples as of when I left to come up here. So it's still a closed area, but it's not terribly surprising since we've got 220 million gallons seeping into the Gulf every year, and that is a pretty active seep area along the slope. So it doesn't surprise me too much.
So it wasn't fingerprinted to a particular spill or whatever you suspect?
We were just saying, was this Macondo oil or not? And it was not Macondo oil.
Okay, here's another question. Could someone comment on the role of oil-eating microbes and the possible impact of seeding contaminated sites with the microbes? I know that there were a fair number of people walking up and down the Gulf saying, buy my microbe and they will eat your oil spill. Does this make sense to anybody? I mean,